Hi everyone, so this is our last lesson for Unit 2, and the third of three lessons when we talk about factoring. The last one's going to talk about factoring trinomials. So remember when I said there were monomials, binomials, and trinomials. So monomials are single terms, let's say 3x. Binomials have two terms, let's say 3x plus 5. And trinomials have three terms, so it could be something like x squared plus 3x plus 5. Okay, so we're going to talk specifically about trinomials. Okay, so equations that look something like this. So this equation is x squared plus x minus 2. Okay, and the typical form is something squared plus something times just x to the 1, or whatever the variable is, to the exponent 1, and a constant. And remember, in our last two lessons, we focused on factoring terms out of these, okay, behind them, and then taking terms that look like this in a nice kind of neat package and multiplying them out using something like FOIL or some of the rules you saw that I posted in the last lesson. But what I want to show you today is how can we quickly and efficiently figure out what these two numbers are and factor this equation really quickly. Okay? In other words, how do we figure out what a and b are? In this instance, a is 2 and b is negative 1. So we want to get it into some form that looks like this: x plus a times x plus b. Okay? So our first scenario we're going to talk about to determine how to do this is assuming that your very first term here has a 1 behind it. In other words, it's just x squared. It's not 2x squared, 4x squared, okay? 6r squared, or whatever the term is. I like using x, but it's not necessarily always x. The term behind it is simply 1, okay? And there's two items that you have to consider when you talk about doing this. The first is you look at the constant. Okay, it's positive 20. And you have to consider all of the factors, which are two terms when two numbers when multiplied together would give you positive 20. Okay, so I've listed all of the factors here. You have to consider both positive and negative instances. So positive 1 times positive 20 is positive 20. 4 times 5 is 20. 2 times 10 is 20. You can also have both numbers being negative. Negative 1 times negative 20 is positive 20. Negative 4 times negative 5 is positive 20. And negative 2 times negative 10 is also positive 20. So that's step number 1, determining a list of all those factors. Step 2 is you have to look at the number or the coefficient behind the middle term here. Okay? In this instance, it's positive 9. So you take each one of these sets of factors and you add them together. Okay? So your first set of factors, positive 1 plus 20 is positive 21. Positive 4 and positive 5 is positive 9. Positive 2 and positive 10 is positive 12. And then for the negative numbers, you'll see it's the equivalent number as what we calculated for the positive ones, just negative. And the goal is that the sum of them has to equal exactly the number that's sitting here. So you can see that the only instance that satisfies that is here, plus 4 and plus 5. They multiplied together, make positive 20, and they add to positive 9. So what you do when you found those factors, remember our original form was x plus a times x plus b. So one of these is a and one of them is b. It doesn't matter which one you place where, but now you simply just place them into that equation. So this then becomes x plus 4 times x plus 5. What I will recommend to you, okay, this seems like after you calculate the factors, the only work you technically have to show is you just plug the numbers in. And it really is that quick of a transition. What I recommend is you always check your work until you start getting more comfortable doing this a little faster. You can always check it by, remember from our last lesson, using FOIL. So if we do that on this instance, we have the first terms, x times x, which is x squared. The outside terms, x plus x times 5 is 5x. The inside terms, 4 times x is 4x. And the last terms, 4 times 5, which gives you positive 20. Now, if you collect like terms, you can collect the 5x and 4x together. You end up with x squared plus 9x plus 20, which you'll see is the same as the equation we started with. So it's always good to check your work that way and make sure that it's correct. So now I'm going to look at 3 examples before we talk about items or trinomials that do not have 1 behind it. So the first question is to factor x squared plus 9x plus 8. So using what we learned in the last slide, the factors are the factors of the number 8, and they have to sum to 9. So our first instance, I know that 2 and 4, 2 times 4 is 8. The sum of those is positive 6. Okay, these are both positive. We can have the exact same but negative, so negative 2 and negative 4 is positive 8 when you multiply them together. When you add those up, you get negative 6. Next, we can have positive 1 and positive 8, right? Because that gives you positive 8 when you multiply them together. And when you add them up, gives you positive 9. Okay? So as you start to write down these factors, well, you look, positive 9. We're trying to get to 9, which is the same number that's sitting here. So we have it. Okay? Once you have that, you remember our equation, x plus a and x plus b. That's what you're factoring this to. You simply substitute those two values in. We could have written more factors there, but once we get to the solution, we might as well just write it out. If we do that, we get x plus 1 times x plus 8. Okay? It's as simple as that. And you can check your work by, again, using FOIL. And if you do that, our first terms, x times x is x squared. Our outside terms, x times 8 is 8x. Our inside terms, 1 times x is simply x. And our last term, 1 times 8 is 8. So if you add those together, you get x squared plus 9x plus 8. Okay? Just collecting like terms. So this is just to check your work. All right? Our second example, factor x squared plus 4x minus 12. So our factors here are trying to get to negative 12. Okay? So whenever you see a negative, you know that one number has to be negative and one number has to be positive when you multiply them together. Because you saw in our last 2 examples, when you had 2 positive numbers multiplied together, they gave you a positive number. And 2 negative numbers multiplied together gave you also a positive number. Okay? That helps you to eliminate some of the factors. So the factors have to multiply to negative 12, and they have to sum to positive 4. So let's start by thinking of a few factors. We could have positive 2 and negative 6. That gives us negative 12. But when you add them up, it gives you negative 4. We could have positive 3 and negative 4. So positive 3 times negative 4 is negative 12. And positive 3 plus negative 4 will give us negative 1. We could, on the flip side, have negative 3 and positive 4. Negative 3 times positive 4 is negative 12. Negative 3 plus 4 is positive 1. Or we could have negative 2 and positive 6. Negative 2 times positive 6 is negative 12. Negative 2 plus 6 is plus 4. So again, you can see that you've reached the number you need. So we know that our factors are negative 2 and 6. So we have x plus a and x plus b. And you simply substitute those values in. So that's x plus negative 2 and x plus 6. So when you have a plus and a minus here, that becomes a minus. This is the same as x minus 2 and x plus 6. Okay? So after you figure out the factors, you simply go from here to here. All right? Again, this is the example where the term, the coefficient behind the squared term is 1. Okay? There's additional steps when it's not 1. So our last example for this, factor x squared plus 2x minus 3. So again, our factors must multiply to negative 3, and they must sum to the number in the middle here, which is positive 2. Okay, so if we think about that, we could have positive 1 and negative 3. Okay, positive 1 times negative 3 is negative 3. Adding those up, we get negative 2. So we're close, right? If we flip that and we go negative 1 and positive 3, negative 1 times positive 3 is negative 3. Adding those two numbers together gives us positive 2. So that matches our value here. So now we can simply write it. We have x plus a times x plus b. And knowing those two factors, that's the same as x minus 1 and x plus 3. You simply take it from there and substitute it in. Okay? So our next item to look at, okay, you saw when we factor it when we just had x here. But what if instead the number behind the square term is not just 1? Okay? Could be 2x squared, could be 4x squared, 1/2 x squared. Okay, it could be any number that's not 1. So we have two options for solving it, or sometimes we might have to use a combination of both options. The first option, which is the easiest one, is to simply factor out that constant behind it. So looking at an example, we have 3x squared plus 9x plus 6. Well, you can see we have a 3 here, and you can also see 9 and 6 are both multiples of 3, right? So 3 times 3 is 9, and 3 times 2 is 6. So we can factor a 3 out of all of them, and if we do that, okay, if we factor a 3 out of each, we have 3 times x squared plus 3x plus 2, okay? So once we have that, now you can just consider everything in here in the brackets and factor just like we did in the first examples. So the factors have to multiply to positive 2, and they have to add to 3. So the two options I have here are positive 1 and positive 2, which gives us the positive 3 that we need, or negative 1 and negative 2, which would give us positive 2, but the sum is negative 3. So we know it's positive 1 and positive 2. So we can simply substitute in just like we did in the past. So now this becomes 3 times x plus 2 times x plus 1. Okay, so that's our first option for solving when that term is not 1. The second option uses a very similar premise and method as the first option. The only difference is in our first option, we always tried to figure out the factors that when multiplied together gave us the value of the constant, c, right? And when you added them up, they had to come out to b. In this case, what we do instead is we take the value behind the x squared term and the constant, and we multiply them together. So a times c equals ac. So let's say it was 2 and 4. 2 times 4 is 8. Now, instead, we find the factors of 8 instead of finding the factors of the original constant. Okay? And that's how we look to solve this problem. Okay? Looking at an example of it, we have 4x squared plus 13x minus 12. Okay, so we can't factor out the 4, right? Because 4 is not a factor in 13. Okay, so instead, what we do is we multiply them together. So 4 times negative 12, it gives you negative 48. So we're looking for factors of negative 48. Okay, and in this case, just like we did in the first instance, the factors have to add up in this case to positive 13. So our first factors, we could have positive 3 and negative 16. That gives us negative 48. Adding them up gives us negative 13, which doesn't work. Positive 2 and negative 24. Multiplying those together gives us negative 48. Adding them up, positive 2 plus negative 24 gives us negative 22. Again, doesn't work. Our third case, negative 3 times positive 16 is negative 48. Adding them up gives us positive 13. Okay? I listed two other ones, but you can quickly see that positive 13 lines up with positive 13 here. So now we follow the same steps, except we substitute that into the equation. So we have 4x squared plus our first factor times x, 16x, minus our second factor times x, 3x. Okay? Well, you typically add them up, but because one's positive and one's negative, we have one as a positive number and one as a negative. And then minus 12. And what you can do now is remember back to our first lesson on factoring. You have two groups, okay? 4x squared minus or plus 16x and negative 3x minus 12. They both have similar factors in them. In the first case, okay, both of them, we have a 4 and a 16. Okay, so 16 is a multiple of 4. So we can factor out the 4, and we can also factor out an x from both, because one is x squared and one is x. So if we factor out a 4x, we're left with just x plus 4. In the second expression, we can actually factor out a negative 3, right? Because this one is negative 3, and negative 12 is actually a multiple of negative 3, right? Because negative 3 times 4 is equal to negative 12. So if we factor out a negative 3, in this instance, we're left with x plus 4, right? Because we want to be able to multiply it out and go backwards to that. So now we see factoring by grouping that both groups have an x plus 4 term. So that means we can factor the x plus 4 out. So if you factor the x plus 4 out, you're left with the two remaining terms, 4x and negative 3. So our final solution is 4x minus 3 times x plus 4. Okay? A couple extra steps, but we end up with the same kind of neat and tidy package as we had in the past. So one last thing I'll note about this before we go through a few examples is sometimes you might have to do a combination of both options. You may have to, you may be able to factor out part of the value in the first term, but not all. And then you would have to do the same steps in option 2. And we'll go through an example of that in a few slides. So our first example, factor 2x squared plus 6x minus 8. So first thing you notice here, this term is not 1, okay, it's 2. And you'll see you have a 6 and an 8, okay? Both of which are multiples of 2, because 2 times 3 is 6, and 2 times 4 is 8, okay? So we can factor out a 2 from all three terms. And if we do that, we're left with 2 times x squared plus 3x minus 4. Okay? So now we have just an x squared with a 1 behind it. Let's see if we can factor this appropriately. So the factors have to multiply to negative 4, and they have to sum to positive 3. So looking at our first instance, we could have negative 1 and positive 4. So negative 1 times positive 4 is negative 4. Adding them together, we get positive 3. So look, okay, we got the answer in the first try. You also could add other terms like positive 2 and negative 2. But if you did that, you'd end up with 0. Okay, so I won't show them all, obviously. You can go through each factor until you find the one that works, right? You could have had positive 1 and negative 4. Okay, that would have given you negative 3. Okay, examples like that. So now we know the factors, so we can simply substitute those in, knowing that it's 2 times, if we were to factor it, x plus a and x plus b. So in this case, it's 2 times x plus 1, okay, in your second term, x minus 4. Okay? Our second example is factor 4x squared plus 4x minus 3. So the first thing to note here is, yeah, the number behind the x term is not 1, it's 4. And you see a 4 here and a 4 here, so you think, oh, maybe I can factor. Well, you can't, because you have a 3 at the end here, right? So you can't factor that 4 out of all the terms. So we have to leave it there. So remember, if we do that, we have an additional step, okay? Our factors have to now sum to 4 times negative 3. In other words, multiplying those two terms together. And that gives you negative 12. And they have to add to the same number here, which is positive 4. So starting with options that we have here, all right, obviously the first one that's going to come to mind is 4 and negative 3. Okay, it's the one we just calculated. So that gives you negative 12, and when you add them up, it gives you positive 1. You can have positive 2 and negative 6 would give you negative 12. So positive 2 plus negative 6 is negative 4. So that doesn't work. It's the negative of what we need. So instead, we could try negative 2 and positive 6. That gives you a value of negative 12. Okay? And when you add them up, it gives you positive 4. So we know what our factors must be. Negative 2 and positive 6. So now we substitute them into this equation. Remember, instead of this 4x, we substitute in those terms multiplied by x. So it becomes 4x squared plus 6x minus 2x minus 3. Okay? Now, we can, in the first two terms, factor out an x. Okay, remember we're grouping them together. So you can factor out an x, but you can also factor out a 2, right? Because 2 times 2 is 4, and 2 times 3 is 6. So we can factor out a 2x, and we're left with 2x plus 3. And that looks awfully close to what we have in the second term, except for the negative. But remember, you can also factor out something like a negative 1. And if we do that, we'd have minus 1. And if we factor a negative 1 out of both these terms then become positive. So we'd have 2x plus 3. Okay? Because if you multiplied that negative 1 into each of these, remember, when you were multiplying them out, you would end up with the exact same expression as you have here. So now we have a 2x plus 3 multiplied by both the 2x and the negative 1. So we can now factor this together, and it becomes 2x plus 3 multiplied by the remaining terms, which are 2x, okay, the term sitting here, and the negative 1, so 2x minus 1. Okay, so a few additional steps when that first number is not 1. Okay, so example number 3. Factor 6x squared minus 33x minus 18. Well, the first item I notice here is there is a number that I can factor out of all three of them. And that's because I know that 2 times 3 is 6, 11 times 3 is 33, and 6 times 3 is 18. So I know I can factor a 3 out of all three of these. Again, all of this comes down to practice to figure these out and find them quicker. So I'm going to start by factoring out a 3 because I can't factor out anything else. If I try and factor out a 6, well, 33 divided by 6 doesn't work. Okay, 18 divided by 6 works. So I'm going to start by factoring a piece out. You don't have to, but you'll see that the math gets quite a bit easier when you do. So if I factor out a 3, I get 3 times. I'm left with 2x squared minus 11x minus 6. So you'll see that the math gets easier because if we didn't do that, we'd have to find factors of 6 times negative 18, which is negative 108. But now that we've taken out a factor of 3, instead, because we cannot get this to get to 1, right? It's going to be 2. We have to find the factors of 2 times negative 6, which is negative 12. So the factors we're finding are for negative 12, and they have to sum to negative 11. Okay, in other words, the number that's sitting here in the middle. So, starting with that, all right, we know we have to get to negative 11, meaning one of the numbers is probably going to have to be, pretty large. So looking at, because it's the negative number, we can start with if we had positive 1 and negative 12. Okay, you could have other factors. You could have positive 2 and negative 6. You could have positive 3 and negative 4, okay, etc. But if we start with positive 1 and negative 12, that gives you a negative 12. And if you sum them up, positive 1 plus negative 12 gives you negative 11. So you can see that we started the first one by getting to the answer. I'll do the other two just so you can see them. Okay, positive 2 and negative 6 gives you negative 12. If you add them up, you get negative 4. Positive 3 and negative 4 gives you negative 12. But if you sum them up, it gives you negative 1. So we know that these two are the factors. So we can now substitute them in. So it equals 3 times 2x squared. And instead of this negative 11, I'm going to substitute those two factors in. Okay, minus 12x plus x minus 6. Because you can see, if I add those up, negative 12x plus x, I get the original negative 11x. So just like we saw in the past, now there's terms that we can factor here. So in the first term, you'll see that I have a 2 and a 12. So 2 times 6 is 12. So we can factor out that 2. So I'm going to factor out a 2. And I can also factor out an x, right? Because one term has x and one term has x squared. So I'll factor out an x, and I'm left with x minus 6. Then plus, what I'm left with is x minus 6. That's the same as putting brackets around it with a 1. Okay? So now I have two terms with x minus 6 multiplied by them. So I can factor out the x minus 6. And we're left with 3 times x minus 6. And what we're left with is the 2x that was here and the positive 1 that was here. So we have 2x plus 1. Okay? So you can see combining both those options together for this, again, just does one additional step by making you have to factor out that constant value here. Okay? So that was all I had for this lesson. Just like in the past lessons, remember the key to this is doing examples and practicing. The only way that you're going to start being able to just figure out those factors faster and faster and faster is by doing practice. So I assign you questions 5 to 36, and again I state odd numbered problems. You can do them all if you'd like. You just won't have access to solutions right away in your back of your textbook. As always, if you have any questions, please feel free to send me an email. Thanks, everybody.